So, as co-chair for this year's Winter Enrichment Program, you helped to choose the theme of personalized medicine. So, why personalized medicine?
Personalized medicine is the wave of the future, how to actually take medicine to the next stage. Over the years, we discovered that not a single solution fits all. You find some patients get treated well with some medicines with certain dosages, and some others don't. So this is something where technology and data would actually help improve the quality of healthcare. Professor Naveen Khashab, which is the chair of this year, and I'm working with her in this field for the last 10 years at KAUST. KAUST in the last couple of months started a couple of new initiatives. One is machine learning and artificial intelligence. The other one was on smart health. And this seemed to be the nice fit because it combines both areas. And at the same time, we launched the bioengineering department at KAUST. So if you look at all these pieces, they fit like a puzzle, and we all were excited about bringing this area to the audience here. People will learn how to actually do slightly better in the healthcare area, how to suit or how to tailor the drugs to the patient, how that each individual is unique and what works for you will not work for me, and what is going on in the research right now in order to actually take advantage of this uniqueness in order to improve the quality of medicines we give to patients.
And you're a professor of electrical engineering, so how does the theme relate to your specific area of expertise?
So I'm a professor of electrical engineering. I started my PhD on DNA sequencing on a chip. So this was like when the DNA sequencing was a big deal, and it was like $15 million to do this. Nowadays you can do that for $1,000.
Wow.
But that's how I started into the area of bioengineering, biomedical devices, and at the time, from a point of view of electrical engineering, this was like science fiction. I mean, we go to conferences and people are like, oh, this is useless. I mean, like, what are you talking about? But then fast forward, and this is becoming like a fact. How to actually develop sensors which actually looks into certain biomarkers in your sweat, in your saliva, in your blood, to figure out that you might have certain predisposition to certain type of diseases. That helps a lot with the early detection of certain diseases. But at the same time, you could also use them to continuously monitoring your blood sugar all the time, so that you can actually accurately give you the right dosage that you need for insulin for diabetic patients. So I work on sensors, and these sensors could be wearable sensors, could be implantable sensors, and these sensors you actually interact with your body in order to sense some biomarker or some kind of physical feature, and then we take an action, and the action is in the form of drug delivery. So oftentimes I work with chemists who actually develop certain drugs and figure out the mechanism of actually delivering them into your bloodstream, while they need the information coming from our hardware. Recently we have been generating a lot of data from our sensors, so this data most of the time could be noise, so you need actually to work with people from statistics and from artificial intelligence and computer science to actually sift through this data and figure out what's useful and what's not useful. And this was only possible in the last few years with the advancement of big computers, lots of processing power that you can do on the spot.
And what's exciting you in that area at the moment?
I mean, there are so many things that are exciting me, but I think the most excited people are my students, because each one of them is like, okay, come with every day was like, oh, I found this new application and this would be cool. One of the big things that we are looking into is not treating diseases, but in general, well-being. I mean, this is actually taking healthcare to the next level. We are interested in prevention, not in the curing, because on the long term, I mean, prevention is much, much more cost effective. And it's also, once you have certain diseases or you're sick, it's actually not a good feeling. But if we can manage to prevent you from getting sick, I think that's actually that's the goal for everyone. And so now we are looking into very, very early detection of certain types of cancers. I mean, we have been doing a good job treating cancers so far, but not good enough. I mean, like, we haven't been able to actually figure out a cure for cancer. But the general consensus, if you can detect them early on, you can do a much, much better in the treatment. So we are looking into certain types of cells that are circulating in your blood, and which is commonly referred to as liquid biopsy. And if we can detect these cells or these hormones in your blood, maybe we can actually make some judgment about you are going to be getting cancer or you have early stage cancer, and then that will help a lot with the treatment. We don't want to wait until it's confirmed that you have cancer and then you start the treatment. Sometimes it's okay, sometimes it's actually too late.
Yeah.
So this is one of the big projects that I'm looking into right now. Another thing is looking into bacteria in our water supply, and there is a big push right now for sustainability, where we are recycling the water that we are using and not using fresh water. They call this gray water.
Yeah.
But the problem with that is that you really need to be continuously monitoring the water supply, because you are doing, and that requires a lot of sensors, requires a lot of technology in order to figure out how much treatment do you need, and whether it's actually treatment at the plant or a treatment at the local house or a building that you're in.
Wow, so there's a lot going on. The thing with the Winter Enrichment Program is it's enriching the students, but obviously you're getting academic experts from around the world. What have you found chairing sessions? Have you learnt things? Have you had your eyes opened about things?
A lot. I mean, like, this was one of the most interesting things because it's highly correlated and related to my field of research. So we had one of the speakers from UCLA, and he actually showed that with a simple second order algebraic equation, it's like so simple that you learn that at high school, you can actually predict which medicine you should be taking for cancer treatment and which dosage. And oftentimes we would actually prescribe the highest dosage possible, but that is had lots of problems with toxicity. So now we can actually find out that using this equation, you can prescribe much lower dosage, but achieve the same level of treatment and efficiency that you could actually do. So this was an eye-opener for me. Tomorrow we're going to be having one of the highly related topics to my work, which is vaccinations not through needles. So they developed these patches with micro needles, so you wouldn't even feel these micro needles, and you put your patch on your skin, it continuously releases the drug in your bloodstream. And this kind of vaccination technology wasn't possible like 10 years ago. And it actually has a huge impact because you don't have to use it for vaccination. You can actually use it for drug delivery. So oftentimes people who are actually diabetic, they have to take insulin shots. And some people are actually afraid of shots. Some people, get really annoyed with having them all the time, while this patch will be there all the time, which means that you can actually continuously release insulin in your bloodstream. And that might be better than just a big spike in your insulin when you get the shot. So that's one of the things that I feel would open a door for new research for my students, where we can incorporate sensors with the patch to do what we call a closed feedback system. So the sensor detects the glucose in your blood or the sugar in your blood, and based on that, we give a signal to the patch, and the patch releases the right amount at the right time rather than releasing it periodically with a prefixed amount.
And the other beauty of the Winter Enrichment Program is that we have Saudi school children both on KAUST campus come in, but also from wider afield. And there's been some very exciting sort of live lectures, particularly for the kids. So maybe we could talk a little bit about that. But also, was there something like that when you were a child that sparked your interest in science, or you already that way interested?
I think I was interested in science because of my parents. Both of them did their PhD. So I was like, growing up, I want to do my PhD like them. So I think that's the early start. Also, I'm kind of an old guy now. So when I grew up, we didn't have internet that widely wide there. And if you have the internet right now, you could actually see all these science shows everywhere. I mean, we were super excited and honored that we have one of our guest lecturers who actually gave the best science show ever for the kids. I mean, like, he made explosions on stage, he made volcanoes, he made colorful gases, and he actually used science to explain all of these experiments, so they got excited. Growing up, we didn't have that. Nowadays, even if you don't get a chance to see him face to face, you can actually watch him on YouTube, so that's actually something useful. At this year, we actually have many things that I think are very good from opening the eyes of students, young and old, for science. One of them is a biofuturist. So she actually a PhD holder in synthetic biology, but she turned into science fiction writer, and she actually talks about how we can augment humans with capabilities that actually improve their quality of life and make them do some superhero type work. It's like Bionic Woman era. She can actually swipe her hand and use that to pay with a credit card. So she has a credit card information in her head, and she just swipes her hand over the machine and she can pay. So that's interesting. We also had a speaker from the London Science Museum, and you can see the excitement for the students because you see the early stage science, and nowadays we can see where it is right now, and you can see the development and how things went from the old days to the new days. So that's actually something that I think students will always, and children will be excited about. So museums were a fun event. The science fiction was fun, and of course science experiments on the stage were extremely fun, and it opens the eyes of students to what's possible, and that you don't have to be a geek, you don't have to be a nerd to do science. It's not a boring career. It's actually could be a super fun.
Great. I think that's a nice point to stop. Thank you so much for your time.
Thank you so much. Thank you.
Great.